Now, for the next step in enabling stereo. These are a few of the objects that we use in our SDK to actually help us with calculating stereo projection and camera offset information. So there's a few objects that we need to create and connect together, which give us the capability to track this stereo information. One thing to note is that none of these objects have any underlying resources associated with them relating to the OS. So, for example, the first thing we do here is we create the zSpace stereo window object. This stereo window object is a data container object, so there's no like window underneath the covers that's actually being created here. It's just a data container. So you create this stereo window with the given sort of position and size, the X, Y, width, and height. Once you have that stereo window, one thing that you need to do is you need to call our left-right frame detect code. And what this does, it allows us to actually ensure that the polarization switch in the display is synchronized with the actual contents of data coming out of the GPU, so that the left buffer goes to the left eye and the right buffer goes to the right eye. And so to call this, it's simply a utility function called initialize. You hand it the stereo window, and then you tell it that you're using OpenGL for your rendering, and then it does all the right things underneath the covers. We have a stereo viewport object. So a stereo window can actually have multiple stereo viewports. The viewport has a position and a size, and this is relative to the stereo window. So in this sample code here, we're simply doing the stereo viewport encompasses the entire area of the stereo